Now here, this diagram shows the interconnection between CPU and other peripherals like input and output devices and a memory. Here you can observe that the address bus is flowing from the microprocessor to the input output devices or a memory. Whereas data bus is a bidirectional bus and a control bus is also a bidirectional bus. This is how the devices are connected on the motherboard with the CPU and with the help of the wires, and that is called as a bus. The first microprocessor was introduced by Intel company in the year 1971. This was the first microprocessor in the market. It has some basic arithmetic as well as logic operation capability. It was extensively used in the calculators. The PMOS technology was used to design these kind of microcontrollers. These microcontrollers were TTL compatible, means they were on plus 5 volt supply. From 1971 to 1973 is called as the first generation of microprocessors. The second generation was from 1973 to 1978. This was the time for 8-bit microprocessors. There were many microprocessors in the market, like from Intel it was 8085 was introduced, from Motorola 6800 and 6801 was introduced, and from Zilong Z80 was introduced. This microprocessor has more speed than the previous one. This microprocessor was designed using NMOS technology. The third generation was from 1979 to 1980. In the third generation, 16-bit microprocessors were introduced like Intel's 8086, 80186, 80286 with improved speed and performance. For the Motorola 68000 and 68001 were introduced. These microcontrollers were designed using HMOS technology, which stands for High Speed MOS technology. The fourth generation of microprocessor is from 1981 to 1995. In this generation, 32-bit microprocessors were introduced. Intel introduced 80386, 80486 microprocessor. The cache memory was introduced in this generation. The cache memory is a separate memory near to the processor and it gives high speed in a computation. Motorola introduced its own microcontroller, that is 68040. The National Semiconductor introduced 32032-bit microprocessor. These microprocessors were designed using HCMOS technology, which stands for High Speed Complementary MOS technology. The fifth generation of the microprocessor was from 1995 to till date. In this generation, 64-bit microprocessors were introduced. In the recent year, multi-core microprocessors were introduced, which increase the speed and the performance of the microprocessor. Applications of microprocessor. The microprocessors are used extensively in day-to-day life, like in washing machine, calculators and gaming console, etc. In industry, the microprocessors are used to control the industrial processes. The second and the most important application in the microprocessor is computer, whether it is a desktop computer or whether it is a laptop. These are used for data processing and entertainment. As we have discussed earlier, there are two types of memories. First type of memory is called as RAM, that is random access memory. This is volatile memory, means when the power goes off, the content within the memory are lost. Further, this memory has two types. One is static RAM and second is dynamic RAM. We will discuss these memories in detail in the next slide. The second type of memory is called as ROM, that is read-only memory. This is a non-volatile memory, means content of the memory are retained even if the power goes off. Further, ROM has four major types, that is PROM, UEPROM, EEPROM and mass ROM. We will discuss these types in detail in the next few slides. The first type of memory is ROM. Within a ROM, we have first type of memory that is called as a P-Rom. So P-Rom stands for Programmable Read-Only Memory, that is in short PROM. It can be programmed only once. It has a fusible links as shown in the figure. If the fusible link is burned out, then it will be store 0. If the link is present, then it will store a logic 1. It requires a separate programmer to store a data within the memory, which is also shown in the slide. The second memory is called as a UV-PROM. UV-PROM stands for Ultraviolet Erasable Programmable Read-Only Memory. In short, UV-PROM. These memories can be programmed using a programmer. To erase the content within the IC, we should place these ICs under the UV light source for 20 minutes or so. As you can see that the UV PROM has a quartz window, so that is shown in the slide. Through this, the memory is exposed to the UV light and the memory is erased. This window is covered when the memory is in the use. It requires a separate programmer to store a data. The next type of ROM is called as Electrically Erasable Programmable Read-Only Memory. In short, it is called as a EEPROM. These kind of memories can be erased using electrical signals. These type of memories can be used more than 10,000 times. Means that they can be erased and used again. The next type of memory is called as master ROM, and these are special kind of memories which are manufactured at foundry level. So foundry means where the ICs are made. The program or the data is sent to the foundry, that is to the factory, and the memories are programmed during the manufacturing process itself. The simplest example of these kind of memories is a SIM card or the smart credit card. This slide shows the internal structure of the master ROM. The next type of ROM is called as a flash memory, and these kind of memories are popular nowadays. Flash memory is a kind of ROM which can be easily used, and we can find many examples in day-to-day life like pen drive or SD card and so on and so forth. The main advantage of these kind of ROMs is that they are very fast. They don't require a separate programmer to program them. It is easy to erase the data. The second type of memory is RAM or the random access memory. These are volatile memories. If the power goes off, the content will be lost. In a RAM, we have two types of RAM. One is called as a static RAM or SRAM, and another is dynamic RAM or the DRAM. The static RAM is consisting of 6 transistors as shown in the slide, which makes one flip-flop, and this one flip-flop stores a single bit. As it requires a 6 flip-flop to store a single bit, its density of this memory is less. But these are very fast in a comparison with the dynamic RAM. In a dynamic RAM, a capacitor is used to store the bit. If a capacitor is charged, then the logic 1 is stored. If the capacitor is discharged, then the logic 0 is stored. As it requires a single capacitor to store the bit, the memory has high density. These are slow memories in comparison with static RAM.